Okay, folks, we'll get going. Just to orient people, we just joined this week. We are at the tail end of a competition that a few of us participated in, which is the brain tumor radiogenomic classification. So we'll end up kind of probably discussing the results or at least a part of the discussion. And then I think since we are in a transition phase, the goal is to also look at the next possible competition that would be of interest to people to participate in. So I think just to orient those of you who just joined in, several of us who were on this call for some time have been participating in this competition called the Brain Tumor Radiogenomic Classification, which is a competition trying to classify brain tumor and a particular aspect of brain tumor and identifying that through MRI scans. That just ended about 10 days back, and we haven't met since it ended. So this session is probably going to be focused on that, but towards the end, we would also spend some time discussing or proposing what's the next competition we ought to choose to participate in, and that is looking forward over the next several months. Any questions before we get started? Okay, if not, I think Steve Mehul, any comments and thoughts? I have some results or things bookmarked that I can begin to share that a couple of you posted.
Yeah, I think you can. Yeah, if you do you have links to some of those top solutions, top 10? It's kind of interesting.
Yeah, I can kind of show. Let me start sharing my screen.
I saw the competition organizers. I don't think anyone learned anything, but anyway, let's see. Yeah,
no, actually, I have a disagreement there, Mehul. I think we learned a lot. I feel because one of the things I'm quite. Let me see. Let me also share because instead of making it abstract, let me share what you had shared that I had not bookmarked. Can you folks see?
Yeah.
Particular tab?
Yeah.
Okay,
yeah.
So this is the one you're referring to, right? I think this is actually a very important. I think this is the youngest member of the Kaggle team trying to join in, right? Mehul, I think you're trying to get. But on a serious note, the competition. This is an important post, I think, that Mehul was referring to with respect to the competition. But what it tells me, where the organizers have shared that. The best results, by the way, just to orient people who haven't been part of the journey, the best results of the classification and or even stepping back further, the goal of the whole competition was to try and identify a particular attribute of brain tumor that typically in practice is only identified through a biopsy, which means you have to go into the brain physically and kind of take a tissue and analyze it and stuff, and then determine what type of cancer or what a particular attribute of the brain cancer is. So this methodology or the attempt was, can a decent identification of that attribute, which was called, I think, the NGMT presence or absence, so 1 or a 0, which is the classification challenge, whether we can identify it without identify it using radiogenomics and MRI scans. 4 different types of MRI scans were provided, rather than having to do a biopsy, and how good of a job the radio scans or MRI scans can do, or methodology can provide us an answer compared to the standard physical testing through biopsy. And the interesting thing that this competition revealed is that the best methods only yielded about a point, if and I may misspeak the number, but about 0.664, something like that. And the metric was the area under the curve. So 0.64 AUC was the best that people could achieve. And if that is the case, then this is not a very reliable method at all. Now, contrast that with some papers that have been published fairly recently, which said that they, meaning the researchers publishing the paper, were seeing up to 0.9 AUC. And as referred to in this post, they talk about exceeding 0.8 AUC in at least one study. So I think, Mehul, where I think that more of such efforts are needed is if we are not careful, I think the hype surrounding ML and AI will get way out of line with what is actually practically achievable in the field. Because as they say in this article, right, I mean, you have to wonder what were the limitations of the study they did to get 0.8, whereas when, as explained in this post, when data sets are different than what you are being trained on, or even slightly different, then you get terrible results.
Yeah. Mm-hmm.
So I think it's a very important identification that, don't rush to conclusions that just because you're able to kind of identify something in very similar looking things, that it's generalizable to things which don't quite look like what you have. And out in the field, as they say in this post, you may get examples of or test cases which are very different from what you have trained on. Right?
Yep.
So I think it's actually contra what you're saying. While it's frustrating, I agree, it's obviously seemed like nothing anybody did seem to provide any answers. And we were discussing multiple times through the competition why the competitors or why the organizers did not provide relevant data and so on and so forth. But I think it did provide a very important result in my assessment, that we have to be careful about the claims.
Yeah, that I agree. Yeah. Part of my frustration is like there's some competitors. I think the person who was 7th, he just did one submission, and he has a post. Even couple of top 30s are like just one submission.
Yeah, but even if you look at the top first, the very first one, and by the way, I'll post this, but here's kind of somebody who has collated all the different places stuff, right? And I did go through the 7th, and actually the post for the 7th is pretty meaningless. What he has posted doesn't tell you anything about what he actually did. I did go through that, so we won't waste our time on that. But if we look at the first one, this one, right, and then he goes through quite a bit of what he did and didn't do, and the code is also on GitHub, and this is pretty good because it at least provides his thought process. What are the things he tried? There's one aspect of it though which pretty much kind of confirms the organizers' results, which is, well, none of this stuff is really worth trusting much compared to the standard biopsy approach. And that this is something I wanted to get Steve's opinion as well on quite a bit, because all he ended up doing, if you look at it and if you look at the code, at least my understanding of the code, is the only thing he calls the best central image trick is the thing that he does is he identifies the slice that has the largest number of pixels in every scan, and then takes a volume, as I understand it, of the X and Y. There is no change. He retains it, I think. And then the depth he adds, he makes this particular slice, which has the largest surface area of the tumor, and he goes 10 up and 10 down, or, you know, think of it as 9 up and 9 down, or whatever, so that the total is 20, with this being the central slice. And that's all he does. And then does a 3D assessment. And I don't think he even segments the tumor.
Yeah, no, from reading his thing, that's what I thought as well. It's like, yeah, like this is like something that we'd tried as well, was just sort of looking at the central image and doing it. I noticed that at the bottom of his post there, he said, yeah, like basically he sort of forgot about the competition and went on holiday, so he didn't even pick his two best models or whatever. They just got picked, picked by random or whatever. And yeah, like I think his winning solution, it wasn't even 0.64. I think he got 0.62. And yeah, like as we'd said, that sort of people were getting sort of scores up around that just by doing random, sort of just setting your seed. So I'm not even sure like his winning solution with his central trick is much better than you'd get by just tossing a coin. And you know, like the competition organizers or whatever saying, oh yeah, like in their private leaderboards, in the private data set, they'd put in other MRI scans from different sources that weren't included in the public training set. Even that, on the public training set, even with that, like we were struggling to get anything to learn at all. So I'm not sure, is it so much down to generalization as like not even being able to fit on their public training set either. And I think the people who had high public leaderboard scores was mostly down to people doing leaderboard probing rather than coming up with good models.
Yeah, I agree. I think the point you're making is, you know, another, I think, good one, which is, if I understand, is saying, you know, besides the fact that the test data is very different, it seems just the inability of the model to generalize at all, regardless of the test data in a way, right? Because it was almost like training, it did train very well. I mean, we saw our training losses go down substantially. But, and I think the other thing I would very strongly commend, or, you know, I mean, it's kind of a known methodology, but the fact that you adopted it, Steve, which is to say, you know, let's plot the AUC curve to really see how much we are learning and show that if we are not learning, then, or if you're learning the opposite, as Mehul pointed out many times, is a 45-degree angle straight line on an AUC curve is actually what you would get if you're, you know, not learning or a random. And in order for your AUC to be actually demonstrate that you're learning on the AUC curve, is your curve has to move away from that diagonal 45-degree line. And we were repeatedly seeing that the curve was barely able to budge, which is what, Steve, I think you're referring to, right? And that illustrated that, you know, from a learning perspective, even the simplest of models. And in fact, he even alludes to it that he was using a very simple CNN model, and it didn't even matter whether you used all kinds of fresh nets or any other kind of thing. I mean, it didn't matter. I think he used a 10 layer ResNet or something. And none of the deeper models had any better success than the very simplest, because none of them were learning much at all. So that, I think, is an interesting point, that it is almost regardless of the test data, the results were poor. But at least to my knowledge, this particular one went into some depth of what he tried to do. And then the other thing which I thought was funny about this post was somewhere here he explains something about his concern that if you, and this was something I think we definitely struggled with or tried to address through our approach, which is adjusting the thickness. Like thickness, I mean the Z dimension, right? Given the X and Y, you can kind of chop some amount of X and Y, but you have, because of the varying MRI types and the varying number of slices that we got in for different patients, it was important. You could only take one of two approaches, or I should say one of two approaches is valid, which is you either upsample everything and keep everything, kind of bring it up to the largest, or you take the smallest number of samples on the depth axis. And one of the things he says is that if you take the approach, he seems to point out that, if you did if you took the smallest approach, then the tumor could be in different parts of the brain and you would miss that information and so on. But then he goes on to actually do this central layer and taking 20 slices or 10 slices on either side of it. And by doing that, he has actually not solved the problem that he supposedly was identifying earlier. And I thought that was kind of strange, because his solution doesn't address the problem that he just seems to have taken the slice that has the largest surface area and then taken plus minus. But which leads me to ask Mehul you the question of, I mean, this is more of a medical question in a sense, but why should if you have a tumor, and since anyway Steve's method kind of segmented the tumor and then picked only the slices where the tumor exists, why should it matter where in the brain the tumor exists? I mean, that is not something that you control in a sense, right? So that point he was making somewhere in this post didn't resonate much with me, that if you take, slices, uniform slices, if you will, but the slices could be from different parts of the brain, but the tumor can be in different parts of the brain, right? Mehul, you still there?
Yeah, I'm not sure where he gets that from. Like, I don't know if there's some like biology that, like certain types of tumor are in certain parts of the brain, but he didn't give any reference.
He didn't give. This is the part where he says in 2 3D images that don't represent the same portion of the brain, thus the model will not only 3D be, right? But
Yeah.
then he goes on to say that, okay, I tried to address this problem, but I failed. So I just went with 10 slice or,
Right.
using the middle slice as.
Yeah.
So I don't see this particular thing as even being a problem other than he just thought it was.
Yeah. Maybe like,
Because his solution doesn't even address it.
like I don't know. Like one thing I could think about was like maybe like let's say these tumors are very very resource hungry, right? So there are certain big um, like the brain uses like 20%. What was it? I think 20% of our oxygen is used by the brain, or
Yeah,
20%.
80% of our basically metabolic energy and that kind of stuff. Yeah.
Yeah. So maybe they are very these tumors eat up a lot of energy. So I don't like one. Is it possible they're growing closer to the blood vessels? But I don't know. We need to see if there's any like that. That could be the only thing I can think of. Like, or
Yeah.
I.
The
Mhm.
other thing, Steve, I was curious about if you looked at his code was I didn't um, go through it line by line. I just kind of scanned it. Does he actually even bother to orient the different scans and get them in the right sequence? He didn't seem to do a lot of that, if I recall.
I'm not sure. Sorry, I didn't actually get a chance to look at his code. I just read the post there, so I wasn't sure if his code was code he'd actually come up with himself, or was it just from one of the EDAs that we'd sort of worked or looked
Yeah,
at?
it seemed like his own code, but I didn't, I didn't see. Of course, I only scanned, so fair warning, it might be there. I just didn't catch it. He didn't even seem to change the orientation, flip the back, order, or do any of those kinds of things with the data, which I thought was very interesting that he didn't even do that. And so it seemed to kind of confirm it just, other than just, and he didn't definitely, if I recall also, he did not slice the X and Y to exclude significant chunks. He just kept the X and Y and just chunked on the Z axis.
Oh, so did he not even sort of exclude the outside of the brain? He didn't sort of trim the images at all?
That's my recollection. I could be wrong.
Yeah, I would need to look
Because
at his code.
at least if I look at his images, he's not reducing it in any way that I saw. But he could have reduced it and just not posted the reduced images too. So I might be wrong there. And as I said, I just scanned the code very quickly to get an idea of what he was doing. But he just, as he says, identifies the middle slice, which has the largest, which, by the way, you had done as well by counting pixels of slices. And in fact, at one time, I was trying to just predict on that one slice in a 2D, but the 2D didn't work very well, meaning it didn't learn very much. I wonder if we just went to a 2D based on just that, how different it would be compared to the 3D stuff.
Well, I tried it, not so much the middle slice, but like once I'd like run the segmentation, I knew which slice had like the maximum amount of tumor on it. And so I tried using that as the central slice. But like, yeah, like I was running 2D CNNs on it. But
yeah, by the way, that is exactly what he does. The one which has what you just said is what is his central slice. By central, he doesn't mean the middle of the tumor. He means the slice which has the largest number of tumor pixels on it.
Right.
I thought he just did largest brain, not tumor. But I could be wrong.
Largest brain, is that what he said? I thought he did the.
Yeah. I didn't see tumor anywhere, but. Yeah.
Oh, yeah, you're right. He uses the biggest image as the cell.
Yeah, so he didn't even go He didn't even look for the tumor at all.
Yeah, that's
Yes. He didn't even segment. That's the thing which also was very interesting to me, right? He didn't even bother to locate the tumor. Which is why I was saying that he didn't slice, to my knowledge, on the by slicing, I mean remove any extraneous pixel in X or Y. He just chunked on the Z based on wherever the largest grain slice on Z on the X and Y was in the Z, chose that as the middle, and then went up and down by a certain amount of slices. But one thing which he avoided by doing this approach is he used whatever resolution the image provided in the depth axis, and he did not normalize in any way on the z-axis. He did not interpolate in any way on the z-axis. Do you follow what I'm saying?
Yeah, that's the thing I was wondering about, like in our code, if that sort of damaged the images. Because like obviously by normalizing and by putting them all into the same orientation and like changing them all so as they had exactly the same number of slices in each direction or whatever, obviously I had to sort of interpolate between each layer to get them to all be the same. And like in doing that, the fuzziness of whatever of sort of sampling them may have sort of damaged the images, whereas like keeping them the original MRI scans and doing what he did, perhaps it preserved any information that was available to sort of identify the MGMT.
Yeah, that's what I noticed. That seems to be an important distinction, I feel, because as we discussed when we were going through the competition, that seems to have helped him quite a bit, right? Because he stuck with whatever Z dimension pixels as they were, and we knew that dimension by the EDA, right? I had done, it showed clearly that there was huge variation on that. Some had 20 slices and some had 500 slices. And we were interpolating to get, let's say, 64 slices. And in case of the images which had 500 slices, obviously 64 slices would be, we were kind of crunching it down. And in case of 20 slice original image to 64, we were kind of interpolating to generate more. Whereas here in his method, he's just using, and this 20 that he chose might very well have been driven by the smallest image, if I recall, depth-wise was 20. So by sticking to that 20, he's kind of accommodating the smallest while taking the same set of chunks from even a 500 slice image. But, you know, key thing, as you point out, Steve, is retaining every slice he has is of the original MRI, nothing interpolated in the Z dimension.
Yeah, so like in retrospect, like our solution, which did the segmentation to identify the tumor, if we had then sort of worked back from that, once we knew where the tumor was in the 240 pixel cube, if we'd worked back to identify where the tumor was in the original DICOM images, then we would have known where the tumor was, and we would have been using the original image without any loss of information on it. So perhaps that may have improved things.
Yeah, that's what I'm thinking too. Because there was all, I think we discussed this a couple of times, but we couldn't come up with an approach that avoided that problem. And his approach of just using, and by the way, it's arguable. Maybe if he had even chosen the slice that had the largest number of pixels of the tumor, maybe his results could have improved too, instead of just using the largest brain as the central one. You know what I'm saying?
Yeah, but without doing segmentation, he wouldn't have known which slice had the most tumor because
That's true. That's
that information wasn't available, and we only knew that by taking the data from the other competition to
But
make the segmentation
then
model.
what you're saying is very true, right? If after segmentation you go back and you just pick the slice which has, the largest pixel rather than the largest number of the largest area of the brain instead of the largest uh, area
Yeah,
of the tumor, then that could improve the results compared to even what he got.
yep.
Interesting. But I doubt even that gets us very far along the path.
No, certainly doesn't get anybody anywhere near what that paper that was published was reporting to get.
Yeah, 0.9. And what is scary was they were saying, therefore, this method is as good as biopsy. And yeah, as Mehul stated repeatedly, man, I would insist on a biopsy if you were in this situation and not go for this. So I guess that paper they published had to have had some caveats around it.
I'm not sure, but like obviously if they're sort of using a small data set and not trying to generalize onto anything else, then perhaps they could learn to just sort of recognize everything within their data set. But as
Yeah.
you saw, like even when we sort of split ours into like training and validation, they would train pretty well, but on the validation set, it just wasn't sort of improving at all with training.
Yeah. Yeah. I mean, it was frustrating going through and disappointing because you never saw things improve or get much better and move off the 45-degree line. But
Yeah,
I think
and
taught some.
obviously, like even in the public test set there, they had like MRI scans coming from a variety of different sources and like a variety of different qualities. And as you say, like they weren't all in the same orientation, and like there was like a big, massive difference in the number of slices in the various sources and stuff. So like if all of their data was coming from a single source and it was all regular and consistent, then perhaps you could get reasonably good validation results, which is what they were showing. Whereas if they were given this data, they probably wouldn't get on so well.
Yeah.
And like, yeah, like the guy that was the competition organizer and writing about the competition, that's pretty much, I think, what he was like saying, that he said he was going to sort of ask the people who'd written the paper to see how their method would get on.
Yeah. And he also pointed to this particular paper of, when even data in the US to data in China, and then it apparently similar thing was demonstrated on two different data sets, but trying to gather the same data.
Yeah. And so, yeah, like in the paragraph below that, the last line of it or the last sentence of it is where he
Right.
says
Yeah.
we're asking them, can they try to see how their thing would get on with this data?
Yeah. 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 In fact, this is something else that I thought was interesting, right? That is,
Yeah.
can you generalize when you even have multiple institutions providing you the data versus you're just using, let's say, data from one hospital or one institution that provides all of your scans?
Yeah, and like that was the trouble with that paper that was like sort of claiming such good results. It didn't publish any code at all. Like it sort of had a couple of images about the model they used, but it didn't actually give their code. So there wasn't any way to sort of verify it.
So interesting learning though. I mean, not after spending so much time and effort, not what we would want to learn, but I still thought it was kind of useful.
Yeah, like I certainly learned a lot about shuffling about three-dimensional numpy arrays. And
A lot of data processing.
yes.
Okay, anybody else had any comment on this competition they wanted to make? Anything else you want to add, Meho?
No, nothing.
Okay, as for the future, so let's look forward of what I think there were. I looked at some of the ongoing competitions. If we want to continue to look at ongoing competitions, and one of them Mehul suggested was this Sartorius cell instance segmentation. So it's a instance segmentation problem, and it still has 2 months to go. The other one is this one, which is that has 2 months to go. That's analyzing some performance of specifically American football special team performance. This one is again a segmentation problem of identifying players' helmets in American football, but again, the issue is there's only 3 days to go, so there's not much time left if you want to choose active competition. So just by default, it seems like the only one which has enough runway if you want to continue to participate in ongoing is this cell instance segmentation problem. On the other hand, if there are different, there's also this one, I guess. I haven't looked at what exactly this is. I think this is something that was run before too, of trying to increase adoption of animals from animal shelters by using photographs to predict which animals or which photographs of animals would result in the animals getting adopted faster.
Is that not the competition that somebody cheated on the last time?
Yeah, exactly. Yeah, and they took away his medal and all that. Yeah, a previous version of this one. Yeah, and there was a big scandal on Kaggle. But if anybody, there was one other thing that, again, let me go. I hadn't looked at. Don't believe that lady is joined today, but she posted or had suggested something else. Let me see. I know this is some new local competition, but this one seems kind of geographically specific.
Yeah, I was looking at that. Yeah, so like every month they have a sort of Kaggle day. And if you look at, there was somewhere in it, it had a schedule. I'm not sure if it's down below. And so I think they have like an actual day each month. and during that day you log on and they announce what they sort of have somebody to describe what the competition is going to be, and then you've got to come up with a solution within that day. But as you say, I think it's geography specific, so it would be for each person in each region, it starts at sort of 4 o'clock in the afternoon, and then you've got until sort of like midnight or whatever to get your submission in. But if you're in different time zones, then it may not work unless you do it by yourself.
Okay, yeah. So that doesn't seem. I mean, if it's
But
that
yeah, if you
focused, then
no, if you just scroll down on the page, on the main page, yeah, it's maybe down a bit below. There was somewhere it was like, yeah, so we've missed the October one. It's over. There's going to be one in November, which in a couple of weeks or whatever, it'll open up for registration. I think it's maybe even below that. Yeah, so I'm not sure. There's like a lot of stuff. As I say, it's the first hour or a couple of hours or whatever is like them explaining what the competition is going to be, but it's all just in a day or whatever you do it. So.
Okay. Anyway, I think doesn't quite like the competitions themselves. I don't know about, but doesn't kind of seem to meet what we would like to accomplish or do.
Yeah, because of the fact that it all takes place in a day as well, you can't really discuss it on here because
exactly.
it's
And
only
if
one
it's
day
all
and then it's
in the
gone.
day, then yeah, and also we're all busy depending on what happens at any particular time. So having it spread out is more important in that sense.
Yeah, so Yuri's just put a link in the chat.
Is this one?
I think so, yeah.
Yeah, so hi. I was thinking of participating in this one. I still haven't decided 100% because it's actually very, very close to what I'm doing at work right now. So it's a positive thing and a negative thing because I cannot use work techniques in it. But it's a different platform, but it's an interesting competition. It's basically predict crops or identify crops using new satellite data. So it's using data from Planet, which is really high resolution data. It basically supplements the usual like a free satellite data that people usually use from either European Space Agency or NASA. So this one is was European Space Agency. So basically what it does, it sort of data is synthesized, so all the clouds are removed. So you get the same data that you would get from Sentinel satellite, but with no clouds. And there are two competitions there. One is to predict crops in South Africa, and the other one is to predict crops in a specific season, because those are two different problems that people are solving. One is you want to kind of learn what's growing after the season, so you have like the whole year of satellite or like growing season of satellite data. And in the second one, you want to predict it early in the season. They use Germany for that. And basically, depending on how weather changes, crops grow at different speeds. So you want to like take advantage of like weather data and try to correlate that. But it's there's no platform. There's a platform to submit, but there's no sort of it's not like a Kaggle competition. I think you submit and you get the score, and it's not very active so far. But.
And do you have any idea how big the data is? Can we do all the?
So like the main data, the the data that they want people to use is huge. It's gigantic. But also because what they do is they take satellite data that's big to begin with, like at 10-meter resolution, and then they use 3-meter resolution to make it better. And also they do it daily. So for the competition, they have sample, which is every 5 days, which is a smaller size. So
I see. Because I think that would be more than the platform, because I mean, we could use Colab, but again, Colab also, the data can't be too huge, or else we'll overrun all of our data posting things on Colab. So that, but worth looking at. So at least interesting, because it's a different domain and we haven't worked on satellite images type of data so far. So,
but ultimately, it's sort of basically kind of LSTM competition, because even though data might look like it's a segmentation problem, really it's a time prediction problem. So typically, like segmentation part is easy. It's really like learning what's growing there from collection of like satellite bands. That's what's difficult. So typically people have like underlying LSTM that takes those like periodic observations, and then they use different techniques to and also like it's typically like in this case there are a lot of like there's a lot of data, but typically there's very sparse labels. So I think here they provide more labels than usual.
On this website, is it like Kaggle in that you can see other people's solutions and like EDAs and things?
No, not solutions, and so far like they're not very active. So you can, I think there was one submission a couple of days ago.
How much do they talk about?
Sorry, Yuri, do you mean that you already do similar kind of thing at your work, or?
Yeah. So actually, like, still, I think I need to get permission from work to participate because it's too close.
Have you already downloaded and played with the data? Does it involve tricky geospatial processing?
No, I know, because I have to join. You have to join first before you get access to data. But there's a video right there. I went through half of the video. Maybe they tell you like actually the video kind of explains what the data is really well.
Okay, thanks.
Okay, so at least we have, I think, on Kaggle at least, unless, one more thought I had is, I mean, I'm open if people are, and there aren't, one active competition choice is this one that Mehul proposed, and it seems to be the one which has the most runway because it ends end of the year, so we still have about 2 full months to go, minus the holidays. But
it only started 2 weeks ago, I think, isn't it? So
yeah, something like that. But so that seems like a good one. If not, obviously anything that has already finished but is interesting is, I'm open to that as well. If people are willing to give it a shot and think that there'd be more interest or learning from that, that's. But which one it is, I don't know, and I'll poke through and see whether there are any recently ended competitions that bring out interesting dynamics. So that's option 2, but with more specifics, I'll try and poke around and suggest a few maybe. And then obviously the third choice is what Uri has proposed, which seems interesting because that how much that has, I think, if I saw correctly, about a little less than the full 2 months, but about 50 days left to go. Now there, I'll poke around and again see whether the data size and other things are such that we can participate. Some that our ability to participate or contribute is not hampered by the size of the data and other issues, because there's no point in, if it's going to be 100 gig or more or something like that, and then not too many people can even though I have 100 gigs on Colab, but about 40 of it is already taken, blah, blah, blah. And that makes it unviable on a day-to-day basis as well. And some of this data extraction on Colab is a pain too, so we have to make sure that it works and we are able to do something with it. So those, if those constraints are okay, then this is another option as well. I'm assuming it provides feedback on your performance when you submit, right, Yuri?
You get the
how
score.
good or how bad you're doing.
Yeah, so I think if you click on leaderboard, should be like one submission before. Yeah.
All right,
Yeah,
so
it'd
be quite easy to get to the top of the leaderboard at the minute.
Yeah, but I think maybe people like are still working.
Yeah.
Or that's like I've seen this with other there are a couple of platforms like this where they host competitions, and it's not as active as Kaggle, so people don't they don't submit as it's not as interactive, and then there's only one Kaggle, and so that's where all the excitement happens. I think here it's more. I think a lot of people who do research in this area, they're participating, or students in geospatial or remote sensing.
So
yeah,
is the main goal
remote sensing is a. Sorry, go ahead.
And
Go ahead,
so I was
Jack.
wondering if the if the main task is image time series classification, is that what it is?
Yeah, it's crop classification, and it's really not an image problem. It's usually a time series problem.
Because we are now working with natural images, is that what you mean?
Because you basically what you do is you either solve it at like a pixel. You basically either take every pixel and solve it for every pixel, or you do segmentation first of the fields, and then you combine average data on the field. But in either case, you get satellite data from that either pixel or field. But it's usually 12 band satellite data. And they might have for the other part of the competition, they might have weather data also, because you want to know if it's the early season, late season, how much rain and temperature changes. So typically what people do is they combine some of the bands to get information specific to crops growing. NDVI is most famous combination, which is basically they take red and infrared and combine it. So basically, when you don't get, basically you look for something which is green, and I think it's a lack of red and presence of infrared. I keep forgetting which, but basically you detect large amount of chlorophyll absorbing data, absorbing red, I think. So you take those satellite bands, which is I think 12 of them, and then you construct some standard band combinations on top of that, and then you see how that changes through the year. So you get time sequence. Typically, like people deal with like 12 months, so you get like 12 data points. But in this case, the full data has like data series for every year, every day of the year. But they recommend they pull data for every 5 days, so it's not so like the amount of data is much smaller. So you get this time series of 5 days for the whole year, and you want to classify them basically. But they're very, very noisy, because and they're very, very close to each other. So that's a difficulty of the classification, because when things are growing, sometimes you can separate them by naked eye, and sometimes it's actually very difficult. But yeah, but they grow like a little bit differently. Like some grow faster. Oh, and the other thing is I think they have SAR data, so you actually can see in the SAR bands, which gives you height. So you one of the bands will tell you like whether how tall the crops are. So.
Yeah, sorry, what's SAR?
Oh, synthetic aperture radar. So typically it's imagery data. So you see multiple bands, so green, normal visible bands plus different infrared bands, and then combinations plus one of the satellites is a synthetic aperture radar. So you get a couple of signals from there that typically tells you the height of what you're observing. So in case of crops, you see whether it's basically bare land or there is some amount of biomass has grown above it.
Okay, thanks. It sounds like you have the right domain knowledge for this challenge,
Yeah.
but I don't know much about it.
Yeah, and I don't have like a lot of experiences actually building applications like this, but we have built some of this, but typically there are people who do it professionally, basically researchers who do it, and we're just trying to like kind of use their solutions.
Okay. Oh, so I'll post link to this, link to the Sartorius, and any other third option of completed competition that might be of interest. Time series is interesting because we haven't done it, and it would be, a useful thing to have in the toolkit. So that's something that is interesting. But I haven't seen a good time series. This one might be that, but subject to data size.
There is another time series competition that I just saw, but I think like you cannot register for it to officially participate in the prize. It's called Volatility Prediction.
Yes, I saw that too, Yuri. I think unfortunately what I saw there is it's already it's one that they repeat, and it's something that I think they started some time back.
Yeah, I don't know if you can submit without being officially registered.
This one?
No, not this one. No, it's.
There's one that was there run by actually something in the stock market area or a company trying to.
Maybe like a little bit down. Yeah, right there.
Yeah, this one.
Yep.
It says 2 months, but I saw that too, that you can't quite, it's already kind of, you had to have registered when they ran it, or when they started it, I think. This one I saw too. I thought it was a good one too, until I figured out what you said, which is,
But so we can. So
But
if
here
you're
it's-
not officially participating, you cannot submit.
I don't know
I took part in a
that,
competition
but
like
what
this. Yeah, about a year ago or a year and a half ago, I took part in a competition like this, and it was it was like a normal Kaggle competition for the first 3 months, and you had to then submit your notebook, which then got evaluated over the coming 6 months or something to see how your notebook actually got on the real stock market. So maybe this is like that.
Yes,
where you
it is like that.
Yeah, so we've missed the period of actually submitting the notebook. So the reason it's got 2 months left is 2 months of the evaluation period.
Yeah, exactly. So that's why I thought something like this would be very interesting, but unfortunately, exactly as Steve said, we needed to have been participating to have made the submission. It's just ongoing for 2 months now because the models are getting evaluated still. But this would have been a really good one, this kind of one. And who knows, the Kaggle competitions have a way of showing up on any given day. They don't have a schedule or anything like that. So I think I'll at least post these 2 options and then poke around to see whether there is anything else in recently finished competitions that might be of interest. That would be a third option. If not, I think we are down to the choice between Sartorius and the one you proposed.
So
Active competition.
what about popularity? The pet competition, is it not a good one to join because of its history or something?
No. Let's see, 2 months to go.
Yeah, there was like an earlier version of this competition, and rather than sort of just analyze the cuteness of pictures, the person that won it, they actually somehow got into like the website of the company that was running the competition, and they sort of took their whole database and put it into their winning solution, because they sort of knew which pets had been actually sort of adopted, right, so or whatever.
He got the ground truth labels to the private test set. Okay.
Yeah.
And then they were sort of thrown out in disgrace when they actually sort of analyzed their winning solution. They found that they'd sort of embedded all of this real data into their solution. They weren't predicting anything at all. They were actually sort of hiding the fact that they knew which pets had been adopted.
Oh, okay, so it wasn't something wrong with the way it was hosted.
No, the hosting was fine. It was the fact that they'd sort of managed to get the real data.
Yeah, and he went to some lengths to camouflage the fact that they were doing it. So they seemed to be doing a lot of calculations, which all turned out to be nonsense. And actually, when they did the predictions and stuff, it was based on the private knowledge of what results existed. So it took Kaggle. I think somebody else analyzed and informed Kaggle that that's what was happening. Actually, the Kaggle guys awarded the prize and then had to retract it.
So I'm new to this group, but on Kaggle, like when you work together, do you merge teams like from the very beginning, or do you kind of do it some other way? Do you just kind of share like insights, your own insights, without merging teams? Or
so let me mention that because so far, so the rules are as follows, and that's relevant. If we participate in an active competition, then this is relevant to us. And I'll tell you the way the rules are the following, and I'll then get into how we didn't have issues and why we did certain things the way we did it. So the rules are that if you are participating in an active competition, you are free to discuss like we are doing right now, but we are not free to share code unless the code is also posted publicly on Kaggle. That's the only limit that we have. The team merger, you don't have to be members of the same team. If you share code between anybody, then you should post that publicly on Kaggle. The merger into teams, there is a deadline. The deadline is usually weeks before the competition ends. And after the deadline, and only 5 people can merge into a single team. And once you're a team, obviously, all restrictions are off. You can share and you need not post the code and so on and so forth. So in order to kind of stay on the safe side of all these restrictions, originally when the Kaggle group was formed, this Kaggle study group, we only participated in completed competition, because in completed competition, you can do whatever you want. It doesn't matter. So you can share code and discuss. And as I said, discussion is never an issue. And you can have how many ever number of people in the same team or individually submit, blah, 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 whatever. Because of lack of interest in the last competition, for example, I think there were only eventually 3 or maybe 4 of us, and who were even discussing it on an active basis. So only 3 of us, and then we 3 formed a team, and so we could just discuss and share code, no issues. If we choose a new competition which is active and on Kaggle, I don't know what the rules are on the other stuff that Steve, that you reposted, but on Kaggle, again, we are free to discuss anything. If we share code, then that needs to be posted on Kaggle if code is shared amongst us. If that is not the case, then that is not an issue. And if that is also after the teams are formed, which happens about a week before, then that is not an issue either. So typically, what we have also done in order to be, and this is something which if you're participating and stuff, then we like to do the EDA and do some of the analysis and all that individually anyway, in order to get an understanding of the competition and to kind of make progress. And if we're doing all that by ourselves and just sharing ideas and stuff, then that's not in any way, shape, or form an issue on Kaggle. So those are the restrictions, and those are the ways in which we make sure we are complying with, and if you're less than 5 and we merge, and that's the other thing too, is we've seen people interested join in the beginning when things are open about choices and stuff, but when it comes to actually weekly doing work or discussing what progress or lack thereof has been made, then we tend to see a drop off in the number of people who stick with competition over longer durations than a week or a couple of weeks.
Okay, thanks for that detailed explanation.
Yeah, so in the last competition there, the one that we were just discussing at the start of this meeting, if you just work by yourself, so like people just join the competition by themselves, and when you do that, it means you've got 5 submissions a day normally, and so you can just try things out yourself. And like, yeah, then in these meetings we would sort of discuss what we'd tried without sharing any code, and then as Srinivas said there at the end, like only with 2 weeks to go, there was only 3 of us left. So like then we joined into a team, and at that point then you drop down from having 5 submissions each, you drop down into having just the 5 submissions for your whole team.
Right. Okay. I see.
So it's best not to sort of join into a team until the end, because you run out of submissions then. So, but it means as well, if you just work individually to start with, each person can try their own thing and just control their own stuff, and then at the end, like most of the time, people that win Kaggle competitions, they win by ensembling their solutions together. So if you come together in a team and ensemble things, then you're probably more likely to do well.
Right. Okay. Yeah.
The one thing I'd say in favor of the segmentation competition is obviously we've looked at some segmentation things in the past. Like we looked at like what the steel defect one when we were segmenting that. And
right. Yeah.
we looked at a while back, we looked at cell segmentation, didn't we? So I haven't looked that closely at this one. But
Steel's defect segmentation, blah, blah, blah. Yeah.
Yeah. There was another one we looked at when it was, I remember it was like 4 band images or whatever, and we were looking at cells.
That was sound thing, right? That the one you're thinking of?
I can't remember what it was called.
Oh, was it the Human Protein Atlas single cell classification?
Yeah, I think it was, yeah.
That was classification though.
Yeah.
That was the very first one we did.
Yeah. So I haven't looked closely at this segmentation one, but like at least we have a sort of a bit of knowledge about segmentation. So.
Yep, that's true. And obviously I'd be curious. We kind of ended that discussion with some, I think, discussing 2 or 3 papers, which were state-of-the-art techniques in segmentation. I wonder now how much further the state-of-the-art has moved, or whether it's kind of pretty much at the same place now as when we left it about, I don't know, maybe a year and a half back. Yeah. Yeah, time series. There's a lot of interest in the geo domain. But I haven't seen any good ones show up on Kaggle. Would be interesting to see how this other platform or whatever that whether we can do it on Colab. That does help if we are. But then computing is definitely a limitation. Could be a limitation, I should say, if data is huge and if processing requires a lot of time. That's the advantage of Kaggle is it also gives you the computing stuff as well. And to your question, yeah, I mean, we can also look at Pet Finder one. Again, if that is just a classification, then I think that might be a reason that since we have done a few classification ones, that we may want to be a bit more challenged in doing something different. So I haven't looked at this one in more detail. I will offline and see whether that's, whether there are any other twists that make it interesting or challenging. Okay, so we have at least 2 good choices, and I'll look into it a little bit more and post some of the findings and see whether anything that's completed could be of interest as well. We'll
I posted another. I'm sorry. I posted another website that hosts competitions. It's just interesting. It's similar to it's like I guess more driven by a problem domain. But yeah, there are like some interesting competitions there.
Yep, I think this at least it has significant time left, and there seems to be I mean there may be more, but this even the first one of predicting seasonal flu in H1N1, that might have a little bit of time series aspect to it, which may be interesting. And we'll do the usual thing of, is the data size reasonable? Can we work on it, and meaning offline, and will the computing requirements be sufficient, and those kind of things. But yeah, thanks. I think this has some interesting approaches and seems to have some time left as well. So that'll be interesting. Okay, thanks, Yuri. We'll look at this, see whether any of the 5 months left. The 9 months, I'm just concerned that if it's that long, people will lose interest, in having a somewhat reasonable end date helps too, because interest tends to wane after a while, trying to work on the same problem. Cool. Okay, so 1 or 2 of these as well. Great. I'll post a summary of all of these different options so people can weigh in with their thoughts and analysis of which one looks interesting, and then maybe after a discussion next week, we'll put it to vote and kind of decide on which one to follow up. But I think the important thing, another thing that I tend to weigh is, how many people will continue to participate. So many people vote and then drop off anyway. So. Okay, great. Thanks a lot, everybody. We'll meet same time next week, 10 a.m. Pacific Saturday.
Cheers.
Talk to you all then.
See you then.
Thanks. See you.
Bye.
Cheers.